Welcome to EPG Pathshala. I am Birzada Rauf and I am teaching at Jindal Global University. In the last lecture, we dealt with issues related to energy crisis in geopolitics. Now we have the second part of it as it's an important topic. The content will be understanding the geopolitics of renewable energy, geopolitics of minerals for renewable energy, and also their future implications. And what can we expect as learning outcomes? It would be appreciate the shift to the renewable energy but to analyze the growing geopolitical disputes over the resources. Also explain the geopolitics of minerals in connection to the renewable energy resources and the criticism of commodification in the most of the natural things. The keywords we are dealing with would be grey literature, the sheikhs versus the shale standoff, and digital disruption. In understanding the geopolitics of renewable resources, we have the geopolitics of renewable energy that has received relatively little attention, especially when considering the far-reaching consequences of a global shift to renewable energy. And with that, we have oil and natural gas, which account for more than half of the global energy consumption and which features close to 70% of the total investment in the energy supply from 2000 to 2050. The world's transportation system, that is, therefore national economies, it depends almost completely on supplies of oil. Yet, geopolitics and the global energy economy are both changing. The traditional definition of geopolitics is the influence of geography upon the foreign relations of states. However, in recent years, the role of non-state actors in international relations has both grown and become increasingly well recognized. The leaders and the policy makers are more and more consumed by transnational threats which pose a great deal of challenge to multiple countries and cross borders, cyber terrorism, which are the most prominent examples alongside the climate change. At the same time, many of the concerns of earlier decades, which have resurfaced in recent years as challenges that have mounted to the international order that has been predominant since the end of World War II. The great power conflict, while unimaginable only a few years ago, is only again in the realm of the possible. Meanwhile, the costs of the solar and the wind power have dropped dramatically, helping renewable energy make significant inroads into the global energy mix. The sales of alternative fuel vehicles, while still small as a percentage of total vehicle sales, have climbed sharply, especially in China. The cross-border renewable energy trade has caused international tensions, including solar trade disputes between European Union and China and between United States and India. The investment in renewable energy is crossing international borders and in some cases is overtaking fossil energy investments. The non-energy companies are investing in major renewable energy projects across the globe, such as Google's investment in the Lake Turkana wild power project in Kenya, Africa's biggest wind farm and the largest single private investment in Kenya's history when completed. This is a news from Guardian. Distributed renewable energy is helping address energy poverty. In India, more than 1 million households are benefiting from solar energy, with over 10,000 remote villages securing basic electricity through distributed renewable power alone. Nonetheless, the geopolitics of renewable energy has received relatively very little study and very little attention. The future of this study and the literature review which is carried out or could be carried out for this report finds that geopolitical consequences of a transition to the renewable energy has received far less attention than the geopolitical consequences of it. For instance, fracking, most research on the geopolitics of renewable energy to date has been conducted by Dutch and German research institutions and largely consisted of grey literature, that's working papers, online reports, dissertations, etc. We also have the geopolitics and the geopolitics of renewable energy, which is very complicated. And the complicated geopolitics of renewable energy in meeting the goals set in 2015 climate conference in Paris, it calls for dramatic changes in the global energy mix. 195 countries agreed on the objective of limiting the global average surface temperature to well below 2 degrees Celsius between pre-industrial levels. To achieve this target, a shift to zero and low carbon energy producing technologies will be required in the near future. We also have with wide deployment of negative carbon technologies, those technologies that remove carbon dioxide from the atmosphere. In second part of the century, we have developed the 20th and the 25th centuries have profoundly shaped, which are shaped by energy geopolitics, which can be defined as the way countries influence one another through energy supply and demand. There is a vast literature that shows how securing the energy supply, especially in the form of natural gas or oil, was and still is an important consideration in many political decisions. Both the high and the oil prices of 70s and today's low oil prices can be attributed to geopolitical considerations. The latest price decline is driven by traditional producers trying to prevent losing market share to US producers who are using new technology to extract oil from shale formations now known as shakes versus the shale standoff. And now in economics, oil has changed some business, and it has, as in today, the balance of power in energy geopolitics is shifting away from the owners of fossil fuel resources to countries that are developing low carbon energy resources. Many believe that alternative technologies like wind and solar energy will lower the geopolitical power of traditional energy producers because low carbon alternatives will provide diversification and increased energy security, especially to those countries that are heavily dependent on fossil fuel imports. That said, predicting the winners and the losers is very difficult because there are so many elements to consider. In the geopolitics of traditional energy, there are clear centers of power on both the supply side, where the Saudi Arabia led OPEC, Russia and United States dominate, and on the demand side, while China and the European Union and again the United States are the most important markets. The participants are familiar with the expected behavior of major players. The geopolitics of renewable energy, on the other hand, is much more complicated affair with numerous decentralized players. Moreover, instead of focusing on just two major resources, oil and natural gas, low carbon energy geopolitics may depend on many additional factors, such as access to technology, power lines, rare earth materials, patents, shortage, and dispatch. That is, rules that prioritize use of different technology sources, not to mention unpredictable government policies. Despite this very complex road ahead, it is possible to take stock of the factors that will determine which nations gain and lose power as the world seeks to lower carbon dioxide emissions. Clean energy versus fossil fuels. Though the cost of producing some non-fossil fuel energy has recently decreased, for it It is to achieve substantial market penetration still requires supportive government policies. Among them are the direct subsidies, carbon pricing, regulations requiring renewable use, and feed-in tariffs. Such climate-friendly policies reduce demand for the fossil fuels and lower the price that coal, oil, and gas producers are paid for their products. The fossil fuel producers believe that tight climate policies are a reality here to stay and foresee the fossil fuel resources may become a standard asset. They may increase production today despite decreasing oil and natural gas prices. For fossil fuel producers, it is better to profit on the resource while it is still valuable, even if they are not getting prices as high as they once were. If the increase of production and lower prices to make these great gains while they can, it would make development of wind and solar power more challenging, as these renewable technologies would find it even harder to compete. The stringency and timing of climate policy will affect the balance of geopolitical power between fossil fuel and non-fossil fuel energy producers. As the Paris Agreement signatories showed, the world recognizes the dangers of climate change and a need for action. At the same time, it is clear that the pledge country makes and submits under the Paris Agreement or submitted under the Paris Agreement, which declare how much and by when will they cut emissions, and not to the sufficient for the stated goal of limiting the increase in temperature to below 2 degrees Celsius. MIT General Program 2015. Many pledges are contingent on financial support and technology transfer that may or may not materialize. Therefore, it is not clear how large the differences might be between the countries pledged and what they actually do. In addition, the Paris Agreement relies on goodwill and therefore are not penalties for common compliance. Even if the agreement is fully implemented, the world energy system would still mostly rely on fossil fuels in 2030, the date for which most of the current targets are specified. As a result, neither fossil fuel nor non-fossil fuel energy producers have much certainty about the direction of the future of the government policies and whether they are likely to see penalties or support. Regardless of the uncertainty, major energy consumers like China, the European Union, and the United States, which are rapidly developing their non-fossil fuel energy sources. For example, the United States increased the share of solar energy from 0.5% to the total power generation in 2005 to 5% in 2015. And by the end of 2015, China had become the country with the largest installed capacity for both wind power 145 gigahertz and solar power 45 gigahertz. This trend will reduce the geopolitical power of traditional fossil fuel suppliers like the Middle East and Russia and increase the technological advantage of major players in renewable energy sector like China, Germany, United States and Japan. There is shifting trend in the future of geopolitics wherein the country with the largest deposit of renewable resources of energy would emerge as a global power. Recently, the world has experienced the crunch of large-scale decline in energy supply through non-renewable means. This has distorted the global power equation and an increasing trend of shifting the power towards country with renewable stock of energy, which has been observed. The emergence of developed economic power while simultaneously having higher HDI, that is Human Development Index, in the form of Scandinavian countries. We, in the third part, will deal with geopolitics of minerals for renewable energy. Motivated by the concerns about climate change, the depletion of fossil fuel reserves, economic competitiveness and innovation, governments around the world have set ambitious targets for renewable energy. The renewable energy technology such as solar panels, wind turbines and batteries of the electric cars, which are highly dependent on number of minerals. One of the critical minerals for renewable energy technologies are rare earth elements, a group of 17 minerals which have received a lot of attention in the media over the past years. Achieving renewable energy targets, which will be very difficult if not impossible without access to these elements. These are several challenges to mineral supply and its security. Minerals are increasingly scarce due to growing demand and limited supply. The trends as population growth, economic growth, and the changing consumption patterns are putting tremendous pressure on the demand and the energy of mineral resources. Supply, by contrast, grows much slower due to the complex mix of factors. The imbalance between demand and supply has resulted in high prices, and countries have to compete with each other over access to limited resources. These developments are of major concern for countries that rely on imports, as well as they are most vulnerable to supply disruptions. Supply disruption risks are high because the production of minerals is concentrated in the limited number of countries. China, for example, produces 97% of rare earth elements and is also a major producer of other minerals. This monopoly gives the country a political leverage over other states. Import-dependent states have formulated policy responses aimed at securing a stable and affordable supply of minerals. Producing countries have also become more active in formulating mineral policy as that they want to benefit from high prices. This has resulted in trend towards government interference, mercantilism and protectionism. The increased role of governments and state-owned enterprises is also related to the rise of state capitalism. Trends in mineral policy have both positive and negative implications for the balance of conflict and cooperation in international relations. The risk of international tension, however, is increased by the transition to a multipolar world in which countries are focusing more on their national interests and international relations, which are becoming more uncertain and unstable. The key minerals which are important are: one way to produce energy from solar rays is to use thin films of photovoltaic cells. To create these thin films, we need a range of minerals that are used like beryllium, tin, indium, hafnium, gallium, other minerals which are silver, cadmium and selenium. The permanent magnets for the electric generators found in wind turbines require rare earth elements, dysprosium and neodymium. Nickel and molybdenum are also used for wind power technology. In the rechargeable batteries of electric vehicles, one can find lithium and tungsten. Platinum is also used as anti-pollution devices and vehicles. Cobalt and magnesium are used in bioenergy technology. The implementation of these technologies at the large scale, however, is problematic as many of these materials are relatively scarce. Mineral scarcity, which in the public debate on mineral scarcity has been similar to the debate on peak oil. The underlying assumption is that mineral reserves are finite. The intuitive conclusion from this so-called static paradigm is that the speed of extraction and consumption will determine the rate of depletion. Due to growing demand, and the demand of production will start struggling as soon as existing deposits have been exhausted and new ones become more difficult to find. However, minerals are not scarce because there are not enough minerals found in the Earth's crust. In fact, rare earth deposits can be found in many places such as China, US, Canada, India, Vietnam, Kazakhstan and Sweden. The total availability of minerals in the Earth's crust in itself is irrelevant for the geopolitics of minerals for the renewable resources. Mineral supply depends on whether known mineral deposits are profitable for extraction with the current or future technology and under the current or the future market conditions. The supply of minerals is limited because under current market conditions, only a small number of countries can mine minerals profitably. China is the largest producer of rare earths because and accounting for 97% of global production. This kind of concentration of mineral production is the result of recent history. China has systematically built up a monopoly on rare earths during last decades. These have been used for the production capacity in other countries, but due to lower wages and less stringent environmental and health legislation in Chinese mining sector. Purchasing rare earth elements from China on the markets become cheaper than maintaining domestic mining capacity. As a consequence, many countries, including the United States of America, closed their domestic production for rare earth elements. Besides rare earths, China is also the biggest or among the biggest producers of tungsten, magnesium, molybdenum, vanadium, gallium, silver, tin, cadmium and indium. And the obstacles to the supply of security and the access to these minerals are a key to achieve renewable energy targets. However, several factors are undermining the supply of security of these minerals. Many countries are highly dependent on mineral imports. The degree of their reliance depends on what services and products countries produce on their economy's position along with supply chain. Countries that produce renewable energy technologies sit closer to the refining stage in the supply chain than other countries. Japan, for example, is an important manufacturer of advanced electronics and is the world's largest consumer of rare earths, for which it is almost fully dependent on China. The European Union has also only very limited mining capacity. There is a domestic mining capacity for some metals in Austria, tungsten, Finland, Greece for bauxite and nickel, Ireland, zinc and lead, Norway, titanium, Poland, copper and silver, Portugal, tungsten, Spain, gold, Sweden, gold and lead. For other metals such as rare earths and the group metals, it relies almost entirely on imports. We have, as a consequence, the European Union, which has classified several raw materials as critical. In the recent report, Critical Raw Materials for European Union in 2010 suggested that an ad hoc working group on defining critical raw material and the European Commission, the following minerals have been identified as critical. At EU level, antimony, indium, beryllium, magnesium, cobalt, platinum group of metals, gallium, rare earths, germanium, tantalum, graphite and tungsten. The criticality of these materials was based on the economic importance of the material, its risk factor and the supply risk, environmental measures which may restrain access to deposits or the supply and the potential for substitution. In the next part, we'll be dealing with future implications. The geopolitical world is experiencing an emerging three-trend model in the energy sector, which is the transition towards more renewable energy and diversified supplies which has created opportunities and challenges for the security of the global energy infrastructure. As renewables are now part of the energy portfolio and are rapidly gaining market share, they bring along benefits such as energy mix diversification with distributed generation growing at a fast pace worldwide and its installed capacity expected to more than double in the next decade. The digital disruption, which is also creating new opportunities, but also the threats. technology which creates grids but also invites cyber attack. The increasing interconnectivity and the proximity of the energy systems means that conflicts can have ripple effects on energy markets and prices. The global ineffective measures to handle cyber crimes have resulted in expectation of a cyber war. Third, the rebalancing of energy supply and demand is leading to a new global energy security order. Recent drops in oil prices have led to significant shift in wealth from net oil exports to oil importers. At the same time, the development of unconventional sources of oil and gas, as well as the recent economic slowdown in emerging markets such as China, India, have contributed to a price adjustment against the backdrop of a general shift in energy supply. The future of renewable energy source will be more centric to the trend in global capitalism. The world will soon witness the energy in use value of air, water, soil into exchange value and still further into the power value. The shifting of energy from the same old means of production might turn the world into a desert unfit for human civilization. This might be the last mode of production ever known to human beings. In the summary of this module, we learned that geopolitics and the global energy economy are both changing. The traditional definition of geopolitics is the influence of geography upon foreign relations of the states. Here we saw there is a shifting trend in the future of geopolitics, wherein the country with the largest deposits of renewable resources of energy would emerge as global power. The shifting to which energy of this energy form with the same old means of production might turn the world into a desert unfit for human civilization. Thank you very much.